If you are looking for some support for current affairs, if you are a fresher, you are a working professional, you are a repeater, but you want some support for current affairs, then I have a program for you. I have given the brochure and also the announcement video link in the description. You can watch if you are interested. Hello all, welcome back to Current Affairs Hitlist series. I am Guna Mathivanan from Office's IAS Academy. In today's video, we are going to discuss about Nobel Prize for Physics. To understand why Nobel Prize was given for physics this time, we will take an example so that you will have complete clarity. Now imagine you have a camera. Now that camera has a shutter speed. So in the lens you will have a shutter. That shutter opens and closes. Okay, that shutter speed. Assume the speed of the shutter to open and close is 1 second. Okay, that is the speed, that is the power of your camera. Now imagine my hand is here, you are in front of me, my hand is here. My hand is moving from this point to this point. The time taken to travel is 1 second. The time taken to travel is 1 second. Now you have that camera with a shutter speed of only 1 second. You take a picture. I am moving this hand, you take a picture. If you take the picture, you will not get a clear picture only. Because in that 1 second, my hand is moving from here to here, the image which you would have taken will be blurred. Image, or maybe you would have captured the hand at this point, or you would have captured my hand at this point, or you will be getting a blurred image. Now imagine if the shutter is able to open and close 10 times in 1 second. In 1 second only, it is able to open and close 10 times. That means in 1 second, it can capture 10 frames. So my hand is here. My hand is moving this point. So when you have 10 frames in 1 second, then you will have relatively better understanding of my hand movement. Now if your camera has a shutter speed of 24 frames per second, that means in 1 second, if it is able to take 24 snaps, so my hand is here, it is coming here, it will take 1 second. Now your camera has 24 FPS, shutter speed is 24 frames per second. Assume my hand from here to come here, it will take 24 snaps. So when you arrange the 24 snaps, you will get a video of my hand in slow motion moving from this part to this part. So slow motion videos we are seeing today in YouTube, Instagram Reels. We see a lot of slow motion videos. A bullet releasing from the gun. How quickly it will be released. But we are able to slowly see the release of the bullet from the gun. That we are able to do because the cameras are becoming so powerful. The shutter speeds are so high. So we are able to capture it. Now you are able to understand. Now imagine I have a camera. That camera has a shutter speed of 1/1000th of a second. That means what? I have 1 second. That 1 second I am dividing it by 1000 times. 1 second I am dividing it by 1000 times. Now I take 1/1000th of a second. My shutter is opening at a speed of 1/1000th of a second. 1/1000th of a second means what? Millisecond. If my shutter speed is that fast, then I can easily watch faster things in a slower motion. There are so many things in the world which is happening quickly. Now think about blink of my eye. My blink of my eye happens in a fraction of a second. My blink of my eye, if you want to capture it slowly, then if your camera has a shutter speed which is, let's say in milliseconds, then imagine my blink of an eye you can easily observe in slow motion. See, I'm giving you an example. I'm just giving an example, okay? Now imagine 1/1000th of a second is millisecond. Now think I'm dividing 1 millisecond by 1000. 1/1000th of a millisecond. 1 second by 1000. 1/1000, that I will get 1 second I am dividing it by 1000. That 1 unit is millisecond. That 1 millisecond only I am dividing it by 1000. then 1 by 1000th of a millisecond. That is called as microsecond. That is called as microsecond. Now that microsecond, imagine I have a powerful camera, shutter speed is 1 microsecond. That means I will get slow motions of so many things is happening at a very faster pace. So many things. Right. Now imagine if I have a camera which has shutter speed of 1 by 1000th of a microsecond. I have 1 by 1000th of a second is millisecond. 1 by 1000th of a millisecond is microsecond. 1 by 1000th of the microsecond, that is called as 1 nanosecond. Imagine my shutter speed is so fast. Like that now, 1 by 1000th of a nanosecond. 1 by 1000th of a nanosecond. I am dividing it. 1 nanosecond. 1 nanosecond is in the order of 10 to the power of minus 9. Now I am bringing it down. I am reducing it. Now assume I come to the situation of 10 to the power of minus 18. So millisecond is 10 to the power of minus 3. Microsecond is 10 to the power of minus 6. Nanosecond is 10 to the power of minus 9. Now think about 10 to the power of minus 18. That is called as attosecond. That is called as attosecond. Are you able to imagine? Now imagine I have a camera, the shutter speed, it can open and close in attoseconds. Then how it would be? Now you might think, sir, it will be very small. It will be very much fraction of a second. Where it is going to be used? You might think where it is going to be used. Now take the subatomic particles. Subatomic particles, inside an atom, you have electrons, you have protons, you have neutrons. These electrons are constantly moving. So if you have a camera which has a shutter speed of attosecond, now you can even capture the movement of electrons. You can capture the movement of electrons. Right? Are you able to understand? See, if you want to visualize this attosecond, see 1 by 10th of a second you are able to visualize. 1 by 100th of the second you are able to imagine. 1 by 1000th of a second you are able to widely imagine. Now 10 to the power of minus 18 you are dividing a second by 10 to the power of 18. Then imagine how fraction it would be. If you want to imagine that, I will give you an example. Now the universe, the entire universe. So we are today. So today is 12th of April 2024. Now let's say the universe. Today we are also the same universe only. The universe was formed 13 billion years ago. The universe was born 13 billion years ago. Now think about the first second of the birth of universe. The first second of the birth of universe. Now we are in 12th April 2024. Now at this point, we would have reached some number of seconds. Imagine a baby is born 5 minutes ago. That means the baby is born 300 seconds ago. We can say like that. The baby is born 300 seconds ago. Now I am saying the universe baby was formed 13 billion years ago. That means it would have formed so many seconds ago. I am converting 13 billion years. That years into days. That days into hours. That hours into seconds. I will be getting some x value. Divide 1 by that x. You will be getting some 0.00000, some fraction amount you will get, right? That fraction amount is called as attosecond. Alright. So the universe was born 13 billion years ago. What was the time taken in seconds? That we will have some seconds, some numerical value of seconds. 1 divided by that numerical value, you will get a fraction. That fraction value is attosecond, just for comparison, or simply understand attosecond is in the order of 10 to the power of minus 18. Nanosecond is in the order of 10 to the power of minus 9. Just imagine that. Okay, so if I have a camera, if I have the shutter speed of 10 to the power of minus 8, if it is of the speed of attosecond, I said even the movement of electrons, because electrons are moving at a greater speed, you want to have slow motions of the electrons, then your camera should have a shutter speed of attosecond, right? Nobel Prize was not given for developing some camera like this. No, this I am explaining for understanding. Now, parallelly, just having a camera alone is not sufficient. See, in a regular camera, you will see something called as flash. You will have something called as flash. The moment you are taking a picture, the shutter opens. During the opening time of the shutter, the flash also appears. Light is also sent. Shutter opens, light is also sent, image is captured. Okay, this is how camera works. We know that. Now, in attosecond, the shutter is going to open. So when that opens, we have to send the light also in attosecond. Are you able to understand? So in regular camera, imagine if shutter speed is 1 second, the flash will go and off, it will get off in 1 second. The flash will also appear and disappear in 1 second. If the shutter speed is 1/10th of a second, then the flash light should also be 1/10th of that second. So if shutter speed is in attosecond, then the light that will be released, right, that should be also in the nature of attosecond. So the light should be sent in such a smaller interval. Only when that light is sent in such a smaller interval, what happens is it can capture. So I am sending a pulse, I am sending a light laser. I am sending a light laser that light laser should be released in an interval of attosecond. Only then the light laser can capture the movements of electrons. If you are sending 1 second light, 2 second light, that is not going to capture. So the shutter speed is of attosecond. The light which we are sending is also in the attosecond. The light will capture, the light will be helpful for capturing the movement of electrons. Are you able to understand? Right? So the development is, so these scientists, the three of them, they were able to develop attosecond pulses of light. That is, they are able to develop light laser pulses. See, I have a light, I switch it on, switch it off. 1 second, I switch on, switch off. If it takes 1 second, the light is available for 1 second. If I switch it on, off in half a second, then the light is available for half a second. If I switch it on and off in attosecond, then the light is available in attosecond. When the light is available in attosecond, if I am able to develop attosecond pulses of light, then with that help of that light, we can understand, we can study, we can see the movement of electrons. Now imagine, you have hydrogen atom, you have oxygen atom. You bring these two together. Hydrogen, plus oxygen, that results in water. Hydrogen atom, oxygen atom, we bring it together, water. See, I have one sodium atom, I have one chlorine atom, I bring it together, it forms sodium chloride, our salt. Now how that is formed? I have one sodium atom, I have one chlorine atom, I have one hydrogen atom, I have one oxygen atom. When that is brought together, it reacts and it forms a new compound. It reacts, right? It reacts to form water. It reacts to form sodium chloride. Can you watch that reaction? My hand movement from here to here, you can watch. That electrons interaction, can you watch? If you want to watch, then first of all, I have to create an attosecond pulses of light and I should have a device. So now, Nobel Prize for Physics was given to these individuals for their effort in developing attosecond pulses of light. So that they have developed. So they were able to generate attosecond pulses of light. So that will help in studying the electrodynamics in the matter. Sir, what is the application? See, if you are able to see the electron movements, see the electron reactions, atom reactions, your understanding about the matter will be, it will become very much improved. Now imagine in medical field, you imagine, right? Let's say I got hurt in my hand. I apply some ointment. This ointment is nothing but chemical. The chemical is nothing but atom. Atom is having electrons. Now these chemicals, when you apply in my skin, my problem gets solved. How it is getting solved? How the medicine reacts in my skin? If I can watch that in real time, I can watch that the electron, it is reacting with my skin, how it is affecting, curing my injury. If I'm able to see it in real time, that will help us to further our understanding in the field of medicine. Alright, so this is going to open up a lot of arena, right? So this Atoc Second development, that is going to open up a lot of arena. We are going to have a lot of developments, applications based on this development, for which we have to wait and see. So for this purpose, Nobel Prize was given for physics. You need not remember the names of the individual. If you are able to remember, okay, but know for what reason they were given Nobel Prize for physics. Okay.